Hi everyone, this is Said from Medonics again, and I'm back with a new tutorial. And it's going to be a series of tutorials, and the topic will be matrix operations in C++. And the reason for bringing up this topic is because I'm going in the future, hopefully, make some tutorials over OpenCV and image processing. And as you may know, image processing is heavily dependent on matrix operations. For example, you do all this kind of cooler stuff, edge detection, I don't know, anything you name it. It all boils down to how good you can operate on matrices and how fast is your matrix operations. So without further ado, let's get inside the code, but let me just explain shortly in the beginning that I assume that you already know what is a matrix and what are the properties of the matrix, and that's why you are here. You just want to know how to write a matrix, for example, in C++ language. So the most basic kind of matrix is just your normal everyday integer array. So for example, if you have an integer array called A and you initialize it with something like 1, 2, 3, so there you go, there you have a matrix. And the property of this matrix, it will be it has only one row, but it has 3 columns. So for example, if you want to print out the content of this matrix, let's assume this is a matrix, which it's kind of a contradiction. It's already a normal one-dimensional array, and also you can look at it as a matrix. So if you want to print 1, you normally do you do the pointer operation and you take the first element and the second and the third one. But let's say you want to have a 2x3 matrix. How are you going to do that? So let's add another integer array, and let's say this one is 4, 5, and 6. I'm awful at typing. Okay. I don't know why they don't match up here. Okay. That's more. That's a better way of writing it. Okay. So these are now 2 distinct arrays. For example, the array A has nothing to do with array B, but you want to have a 2x3 matrix, and how are you going to do that? It's simple. You just need a variable that holds the address to each individual array. Then you can call it a matrix. So let's try it. I will make a pointer of arrays, and I will call it matrix. And I just initialize it with A and B, the pointers to the A and B array. Now we have a matrix that we can call see the elements with I and J notation, I for the row number and J for the column number. So let's try to print out this matrix and see if it works or not. So we're just going to write a code, and I just assume that we have 2 rows, and this loop goes over the rows. For example, first it goes over A, and then it goes over B, and within this loop we need another loop for the columns. And let's say we have 3 columns, and actually we have, this is our first column, this is first column, this is the second column, and this is the third column. So we just simply say cout then the matrix at row I and at column J, and let's just pad it with 1 space so it prints out nicely. And after printing each row, we just print a new line so it looks good. And there you have it. You have a basic matrix, and you can print the content. So let's try it. As you can see, this is our hello world. I forgot to delete it. We don't need it. Okay. And this is our matrix. It's the first row, 1, 2, 3, and second row, 4, 5, 6. So the trick here is that without the pointer to the each single row, then you couldn't have a way to tell what comes after A, because the way the values are set into the computer memory. So now let's do a bit more with this matrix. I would just call this matrix A, and for some reason that we will find out later, we need to store the number of rows and number of columns of the matrix in two separate variables. So I would say mat A rows equals 2, because we're going to have 2 rows, and mat A calls for columns equals 3. And then we simply update our loop condition, and for this one we call mat A rows, and for the J4 we replace it with mat A calls for the columns. So this is a more abstract way of doing things, and let's just, for sake of fun, let's try another matrix. Let's just copy paste this one, and I will just rename every A with B. So let's change these elements. For example, I'm just going to have it reversed: 6, 5, 4, 3, 2, 1. So let's print this out and see what happens. And I think I better to put a end line between these. Let's try it again. So now we have two distinct matrices. One is 1, 2, 3, 4, 5, 6, and the other one is 6, 4, 6, 5, 4, 3, 2, 1. So using this method, you can create any matrix that you like, but it's going to be, as you can see, this code is not going to be manageable if you are going to try with like hundreds of matrices. And if you want to pass these matrices to other classes or other functions, then you have to make some classes or functions that take a lot of arguments. For example, the pointer to this matrix, then the number of rows, the number of calls, and it quickly becomes out of hand. So what we need here is a kind of an abstraction, and by that I mean that we make a function, for example, that will return a double pointer, and we call it generate matrix, and it will generate for us a matrix by this many rows and this many columns. Okay. So, and if we use this method, then if we create something here on the stack, then when the function goes out of scope, then that variable is going to disappear from memory. So we need to allocate the matrix on the memory, on the heap. So how we do that in C++ is simply we would create our array. For example, I would say int temp, and this int will be double pointer equals new int of a new int pointer array, and the size will be of size rows. So again, we have a variable that is called temp, and it's a double pointer to an array of pointers which the size is equal to the rows that we want. So this is exactly the same as this one. So what we will get back from this function will be this variable. Okay, then we have to allocate memory for the columns as well. So we're going to have a quick loop over rows, and then we assign each element of temp variable a new int array of size calls. I hope you understand this code, because it's just simply equal to this, but in a more neat way. So, and at the end we just return the temp variable that we just created. And by allocating this array on the heap, we assure that when this pointer is being returned, it's not going to be suddenly disappear from your code. So let's see how we can use this method. So I'm going to get rid of the code here, and for the sake of simplicity, I will also create another function, and I call it print matrix. And the first argument will be a pointer to a matrix, and as you can guess, we already know what the pointer will be. It's a double pointer, so we'd say int double pointer matrix. Then we need to know the number of rows and also the number of columns. Okay, 4 rows for j less than calls. Okay, we just say cout again, and we print the element at row I and at column j. And again, we need this padding. And after each printing each row, we need a new line. So yeah, so this is more like it. And let's try it. But again, we need for each matrix to have two integers to denote how many rows and columns it will have. So let's say I have a matrix called M1. Okay, so let's call this our first matrix, and I would say int M1 rows, number of rows in matrix 1 equals, for example, I don't know, 3. Let's have, for example, a 3 by 5 matrix, and mvol equals 5. Now I'm going to say int a double pointer of integer and call it m1. Then it will be simply equal to what we can get from the generate matrix function that we just wrote here, and we want m1 rows, number of rows, and m1 calls, number of columns. So you can compare it to our old code, and you can see this is much more cleaner way of doing things. And let's have another matrix, our second matrix, and let's, for this one, we just do the same thing. Let's rename to M2 and M2, and this one also M2. And for sake of completeness, we just rename the arguments as well. So we have two matrices with the same size, and by the size mean the number of rows and the number of columns are equal in both these matrices. And the problem now is we don't have a way to initialize the matrix. So let's make a function that reads from an array and populate the elements of the matrix with those values. So here I'm going to make a new function, and I call it void populate matrix. And again, we get a reference to the matrix. We need the number of rows and number of columns, otherwise we cannot iterate through the elements of the matrix. And we get a pointer to an one-dimensional array, and you will see how we're going to use it. And we just call this source. Well, let's say src is more clear. So again, we just make a loop, number of rows, and another loop, number of columns, and we say matrix at I, the element at row I and the column j equals source, and we need to introduce a new variable to keep track of how far we are going inside this source array. So I'll just call it int pos for position. Source pos plus plus. And that's it. We can improve this method even more by introducing a new argument for the size of the source. I would call it source size, so the number of elements in the source. And at the beginning we just check that if they match or not. So let's say if rows times calls does not equal source size, then we know for sure that the loop here will going to cause a segmentation fault on Linux or some memory error in Windows. So we just exit with -1 here, and let's print something. CO size of matrix is not equal size of source array. Okay, this is just some kind of idiot proof function so to speak. And how we can use this, for example, we had here a 3 by 5, and I changed my mind, I want to make it 2 by 2. So because this is easier to make the source array, int m1 source equals 2 by 2 will be equal to 4 numbers, 1, 2, 3, and 4. And let's call for this one int m2 source will be 1. No, let's make it the reverse of that. 4, 3, 2, 1. And for each matrix we're going to populate it using the source array. For example, we say populate matrix, then we pass in m1, then m1 rows, m1 columns, m1 source, and we just hard code the size of the source as 4. And we will do the same thing for the m2 populate matrix, m2 rows, m2 columns, m2 source, and again we hard code the size by 4. And now let's just print these two matrices and see if we did everything right. So print matrix m1 rows, m1 columns. A new line before printing the m2. Okay, m2 rows and m2 columns. Okay, so let's try this code. Okay, I'm going to run it, and as you guessed, the size of array is not equal to size of source, and the problem was here. And happily we wrote this check, and it prevented our program from doing something catastrophic. So I simply need to make this 2 by 2 for the matrix number 2, and let's try again the code. And we have a problem here. As you can see, m1, we did populate the m1 with 1, 2, 3, and 4, and it seems that we got 3, 4, -2, and this variable here, let me make it bigger, 3, 4, -2, and this is not something cool. This is something just a random number in the memory. And for the second one, we had 4, 3, 2, 1, and we got 2, 1, 1, 2. So there's something funny going on in our code, and I will try to find it now. So let's go together and see. So, okay, This is the problem with the C++. If you forget to initialize your variables, then you get this kind of undefined behavior. So I had forgotten to initialize pose with 0, and that's what you get. Now it should work fine. Yes, it does. So the first matrix has 1, 2, 3, 4, and the second one is 4, 3, 2, 1. So now that we have it, let's make something cool. For example, we want to add these two matrices together, and as you know, addition in the matrices are just the element-wise addition of each element. For example, the element at matrix A at row I and column J will be added by matrix B element at row I and J. So let's make a new matrix. I call it result matrix. And as you know, if you add two matrices together, the first rule is that they have to be on same size. I mean, the number of rows and the number of columns should equal. And therefore, the resulting matrix will be of the same size. So let's say int r rows equals 2, int r cols, and r here is result matrix. And let's make the matrix itself int double pointer result equals generate a matrix, and we want to by r number of rows and r cols. Okay, so let's define a new method here. I will call it void add matrices. So it will be matrix A, matrix B, and number of rows and number of cols. Okay, and let's return the pointer to the result instead. So we make the resulting matrix here. So forget about this line here. Result mat equals generate matrix. So we know that we will have the same rows and columns as the matrix operand. And for each row and for each column, result mat at row I at column J will be equal to mat the first matrix on the left hand side at row I and column J plus the right hand side matrix at row I and at column J, and at the end we just return the result matrix. Okay, now simply let's see what will be the addition of these two matrices will be. So you can guess it, the first element will be added by the first element of this one, so it will be 5, and this will be 5, and this will be 5, and this will be 5. So we need to get a matrix, 2 by 2 matrix, which all the elements are 5. That's way we know that our code works fine. So let's try it. Print matrix. And I'm just going to pass the pointer just from this add matrix function. I'll pass M1, M2, and just M1 rows and M1 columns. Okay. And too few arguments. What will be argument should be? A, B rows, cols. Okay. Okay, yes. Then we need to pass the M1 rows and one columns here as well. So let's print the content. Oh, it's already going to print it for us, so let's see the result. And as you expected, we have a result of the matrix by 5, 5, 5, 5. So let's just, for the sake of argument, make all of this 10. Then the result should be 14, 13, 12, and 1. Now, there you have it. So, using these three functions, we made a lot of abstraction, and we made it easy that we can at least create more manageable matrices instead of hard coding them like we had in the beginning. But in the next tutorial, we will discuss how to write our own matrix type or the class. And as you saw here, all our matrices will be of type integer. But what if you need something matrix of type float or double? So in next tutorial, we will make a template class which will contain all these useful functions for generating, printing, and addition, and also the subtraction, multiplication, and division. And that will be all for the next tutorial. So I hope you enjoyed this tutorial, and I hope to see you in the next one as well. So goodbye.